In these examples, we're going to look at equations and expressions. Quick review going from combining like terms all the way through solving equations with distribution on both sides. So let's start to review with combining like terms. We'll put a simple example up first. We'll do 2x plus 3 minus x minus 6. Now it's important to get in a habit of marking your terms and to get those combined before you take any further steps. Now in this case, this is our only step. I'm going to circle my terms that have x in them. And remember that the sign in front of the term is a part of that term. The sign afterwards goes with the next term. So what you're doing is splitting this into two different problems. You've got 2x and you have negative x. When you put those together, it's the same as 2x minus x, which is 1x. And in algebra, we'll just mark that as an x. Secondly, you have positive 3 and a negative 6. So 3 minus 6 gives you negative 3. And that is as far as you can go. You're not solving, there's no equal sign. So all you're doing is simplifying. So in combining like terms, make sure you don't just do 2 plus 3 is 5, minus 1 is 4, minus 6 is negative 2, and put an x behind it. That won't work. You have to keep those separate. If you have multiple letters, you'll keep each of those in a different term. So in this case, if I had added 2y at the end of this, then in my answer step, instead of this being my final stage, let's just erase that whole thing. Get the pen active again. It would have x minus 3 plus 2y. Now the order comes more important later. At this point, it's not important just yet. Okay? Now moving on to the next thing, distributing. The distribution property states that when you have a number multiplied by a sum or difference in grouping symbols, such as these parentheses, what you're doing is two multiplication steps. The first one is 4 times 2x, and the second problem is 4 times 1. So 4 times 2x gives you 8x. And since this is 4 times positive 1, it's a positive 4. And add, positive, plus are all the same thing. So don't let that confuse you. You want to avoid any double signs at all. Now, let's step it up a notch and put some negatives in there. Let's do negative 2 multiplied by the difference of x minus 1. When you're paying attention to these signs, this problem is actually negative 2 times x. And your second problem is actually negative 2 times negative 1. So when you put those together, negative 2 times x gives you negative 2x. Negative 2 times negative 1 gives you a positive 2. So you'll record that as negative 2x plus 2. And that'll be your final answer to those two examples. All right, let's look at a new approach to the distribution property here, and we'll look at it as a combination of combining like terms and distributing. So let's do 3 times x minus 1 minus 2 times x plus 1. Now this looks longer. There's a couple more steps, but the same process is applied. The first step is 3 times x, which is 3x. Your second step would be 3 times negative 1, which will give you negative 3. That gets you to right here in your problem. So now you follow that with negative 2 times x, which is negative 2x, just working left to right. And then finally negative 2 times a positive 1, which is a negative 2. Now you're not at your final answer. Since you have like terms, you need to put those together. So I always start at x's. So you have 3x minus 2x. Just skip negative 3 and negative 2 for right now, and that gives you just x. Negative 3 minus 2 gives you negative 5. So that is the simplified version of that problem. Now let's continue on to one-step equations. One-step equations are solvable with one step. So we'll start out with x minus 3 equals negative 4. Your goal is to always isolate your variable where x equals your answer. So you always plan your attack from the side with the variable by undoing anything done to the variable. Since 3 has been subtracted from x, to solve for x, you will add 3. And when working with equations, it's important anything you do to one side, you instantly do to the opposite side in the same step. Now, I always start at my equal sign and then copy down what I have on the left and right. So if I put my equal sign here, what I have is negative 3 with 3 added to it. When I do that, this cancels out and leaves my x on the left. On the right, I answer the problem negative 4 plus 3, which is negative 1, and I reach my solution, x is negative 1. As a similar problem, let's do x plus 1 equals 7. So again, I'm going to start at my variable side. This has 1 being added to x. So what I want to do is the opposite of that. I'm going to show it on top instead of underneath as I did in the last example. It's just another version of showing your work that you may like better. Since 1 was added to x, I'm going to undo that by subtracting 1 from both sides. The result that gives me is that these cancel again, so I'm left with x on the left. 7 minus 1 gives me 6 on the right. And again, since it's a one-step equation, that's all there is. Now let's look at one with something else happening to your variable. In this case, you have x being divided by 2 to give you negative 3. I'm going to undo division by 2 by multiplying both sides by 2. Now what this actually does is makes this 2 times x, which is 2x, divided by 2. Well, 2 divided by 2 is 1, so I'm left with just x. On the right side, I have negative 3 times 2, which is negative 6. So again, in one step, that's been solved. And the last example, we'll do 2x equals 4. So on the variable side, I have x being multiplied by 2. So the opposite of multiplying by 2 is divide by 2. Show that as a fraction. Again, same as our net result up here, you have 2 divided by 2 gives you 1x, and 4 divided by 2 is 2. Next, let's look at equations that take a little bit more to solve. It's called two-step equations. You have to do 2 things to reach your answer. We'll look at 2x minus 7 equals 3, and we'll look at x divided by 4 plus 1 equals negative 5 as our examples. Now you're essentially doing order of operations in reverse for order of solutions. The last thing that you would do in order of operations is the first thing that you want to do when solving an equation. So addition and subtraction come last in order of operations, so they're going to come first now. I'm going to add 7 to both sides to undo negative 7 being subtracted from my variable term. So my net result in my next step, since these will cancel, will be 2x on the left, and 3 plus 7 gives me 10 on the right. And just as I solved this problem as a one-step equation, I'm going to do the same technique here. I'm going to solve this new step now. This is x times 2, so you'll divide by 2. And you do that to both sides. So on the left side of my equal sign, 2 divided by 2 is 1x. 10 divided by 2 is 5, and you've reached solution. Again, starting with any addition or subtraction first, I have 1 being added to my variable term. So I'm going to subtract 1 from both sides. Use my equals point as a reference. So I have x divided by 4 equals Negative 5 minus 1 more is negative 6. Now, what is the opposite of x divided by 4? The opposite of divide by 4 is to multiply by 4. So that's what you do on both sides. 4x divided by 4 is x, so the 4's cancel. And negative 6 times 4 gives you negative 24. So there's how you solve two-step equations. Right, and now let's look at variables when they show up on both sides of the equation. Let's start out with one with three terms. You have 7x on the left, you have 5x plus 4 on the right-hand side. Now your goal is to look at your two sides of the equal sign. You have an x on both sides, you have a number by itself on only one side. Good rule of thumb is to subtract your smaller x value from both sides. It's like a scale. I want to take the same amount away from both sides of the scale so it stays level, and the equation must always stay level. So I'm going to take 5x's away from both sides. 7x minus 5x gives me 2x on the left. I have eliminated my 5x's over here, giving me 2x equals 4. Now, 2 times what number gives you 4? That's obviously 2. And the mathematical way of showing that is to divide both sides by 2. Now, that can get just a little bit more complex, and we'll work more with that later in the year. But let's try adding in a fourth term. Let's make it 5x plus 4 equals 3x minus 2. Now, just as a tip on getting better at this, look at your two sides of your equal sign, find your smaller value of x, which would be 3x, and start there. If you move the smaller value, you typically will end up with a positive x value, because 5x minus 3x is going to give me 2x. Now that 2x is going to be on the left side of my equal sign. I'll no longer have x's on the right side. I could also, at that step, go ahead and subtract 4 from both sides, but I'm not going to do that just yet. We'll keep it in separate steps for now. Now, if my 2x is on the left, I want my constants, my numbers by themselves, on the right. I need to get rid of this plus 4. So let's subtract 4 from both sides. So I'm left with 2x, since these cancel, equals negative 6. What number times 2 is negative 6? X will be negative 3. And mathematically show that by dividing by 2 on both sides. 2 divided by 2 is 1x. Negative 6 divided by 2 is negative 3. And one last example. Let's add the process of distribution into our work. 2 times the difference of a minus 2 equals 3 times the difference of a minus 5. My pen isn't working good there. There we go. Now, when you distribute, remember you're multiplying twice. Remember you're keeping the signs in the problem. Don't add signs prematurely. Your first step is 2 times a, that's 2a. Your second step is 2 multiplied by negative 2, which is negative 4. Notice I'm not putting that sign in until I know my outcome. Equals 3a, and then 3 times negative 5 is negative 15. Now, using the rule of thumb there, subtract your smaller a value first. We'll work underneath this time. Minus 2a, minus 2a from both sides. Keep the scale balanced. Now, when you do that, the a's will disappear here. Let's put my equal sign as a reference. 3a minus 2a gives me just a. And that's on the right side. So I'm going to want all my constants to move from here over to the left side, and the way I do that, since that's a negative 15, is to add 15 to both sides. Now I'm just going to go back and do it on the previous step. So we have a negative 4 plus 15, which is also the same as 15 minus 4, which is 11. And that's your solution step. That is completing the problem. Now later on we'll work with problems that have no solutions, and we'll also have problems that have infinite solutions. So those are found on pages 424 through 427, so keep your eyes open for that. You may want to look for the examples on page 426. Examples 3 and 4 will explain those, and I'll get a video posted on that soon. But there's your review on equations and expressions. Good luck.